Welcome to Turn Right Machine Works. My name is Keith, and today we're down here at the boat show, and I want to introduce you to my friend Don Chapin. What do we have behind us here?
Well, what we've got behind us is a 26-foot launch that's electric powered. Thanks to a lot of your machine work, it's actually almost ready to go in the water.
All right, we're going to take a look around and get a few highlights here and get Don's feel on why he chose this design and what this is all about. What kind of hull is this?
This is a double wedge torpedo stern hull. It's a very narrow hull form. It's the most efficient hull form for making speed with very, very small power. The boat is electric, and what we were trying to do was accomplish the best range and speed with the smallest amount of power input.
Okay, and what are you powering it with?
This is kind of unique. It's powered by an AC motor, so we take 48 volt DC and we convert it to 48 volt AC.
All right, and let's take a look at the motor itself. We got it sitting here.
All right, what's really unique about the AC motor is we take the DC power and it goes into a controller, which is also an inverter, which inverts the power from 48 volt DC to 48 volt AC, and then it feeds the motor. The benefit to the AC is higher efficiency. We get 100% of our torque from 0 RPM, and also we have we have a lot of expandable programmability. In other words, we can adjust it to work as a diesel engine. In other words, it's torque control, and the speed changes to apply the same torque. It can be adjusted for RPM like a gas motor, where it's going to give us speed and as the controlling factor. It also, you'll notice on the mount here is one of the pieces that Turn Right makes for us. This is a Yanmar 3YM20 mount. It matches the mounting pattern of that Yanmar, so we can take a motor out of a boat, I designed the mount as well as the height of the shaft from the mounting surface to match whatever was in the boat. Then Keith CNC cuts the parts for us, welds them together, and confirms that everything is to spec. And then we mount a motor that's been wound specifically for that hull and shaft and propeller combination to that mount, and it sets right into the boat with no transmission. It's direct drive. It's a very simple system. Some of the important features that you gain when you go to the AC system is in the programmability. There's a lot of things that we can do with an AC system that we can't do with a DC drive system or with the general type of DC drive system. Let me go through some of the interface between the operator and the system to explain that to you. Down below we have battery bank selector switches, so you can turn on or off either battery bank. We have a gauge down here. You probably can't really see, but it's our secondary gauge. That just gives us some system information with a momentary switch that toggles through various bits of information. The key switch to arm the system is here at the bottom as well. Once you're set up to run, you can put this door back on and close that off. Now as we get up on top, we have a couple of really kind of important things. We have an emergency run stop switch. So we always would start with the switch in the stop position and ensure that our throttle is centered in the detent. Then when we turn it on, we're ready to move the boat simply by pulling it for reverse or pushing forward for forward. Because the AC system has so much torque to it, it really accelerates quite fast. When we're docking, we don't want that same burst of energy. We flip the switch down, a little red light turns on, it tells us that we're in docking mode. What that does is it changes the throttle. It still has the same amount of movement, but at a lot lower speed, and that's something that I can adjust with a handheld programmer attached to the controller. We also have a touch screen here. This is a master volt system that uses a battery shunt to tell us exactly how much remaining current we have in the battery, as well as how much time we have remaining at our current speed. So what you can do is, as you're moving along at any given speed, you can look at how much power you're using and then see the difference as you slow down or speed up as to how it affects your range. Basically what happens with an electric motor in a boat is that as you go from, say, 7 knots to 10 knots, so roughly half again as fast, you use 5 times as much battery power. With this hull being such a fine, narrow hull, and being the best possible hull we could put together for low power use, that's not as extreme as it would be in a more modern hull, but nonetheless you want to be able to know, just like in a Honda Prius, you can tell how efficient you're operating, and that's really important in an electric vehicle. One of the great things about building boats on a custom level is that you can do things and experiment with things that would generally never be done in a production boat. And then having someone like Keith at Turnright that's local and who is absolutely committed to finding the best way to do things really helps quite a bit. This is one section of the boat, one area of the boat where Keith had quite a lot that he did for us. For instance, he built or turned down the rudder post for us out of stainless. And the rudder's kind of unique. It's a McClear Thistle rudder, which is a fish form type rudder. It's got a aerodynamic shape with a flare out at the trailing edge, and then it's got plates top and bottom. This type of rudder will actually be effective out to 40 or almost 45 degrees, as opposed to a standard plate rudder which stalls at about 30 to 35 degrees. So this should allow us to pretty much walk the boat sideways at slow speed. Some of the other things that Keith has done for us, the cutlass bearing is threaded. It's something you've probably seen on his site in the past. It's just really unique. I wanted to make the boat as low maintenance and as simple maintenance as possible, and that's one of the things that Keith has done for others that he did for us. You simply put a nut and use a spanner wrench, and you can walk the cutlass bearing right out of the shaft tube. Another thing, but that's not as apparent, but I think is really unique and important, is this is a laminated plywood keel. And for the skeg bar, we didn't want to take lag bolts or hanger bolts and put them up through the laminations. So what Keith did is he took some blocks about 3.5 inches long of 2-inch shaft, cross-drilled them and threaded them for me for half 13, and I've embedded these in the keel above each of these bolt holes in the skeg bar, and there's a fiberglass tube that joins the bolt through this passage, and the bolt simply goes up through the tube into that. So I can take the skeg on and off an unlimited number of times and not worry about degrading the integrity of the keel. And again, that's simply going to Keith and looking for a solution, and Keith sharing some of his machining knowledge with us to make the boat better.
Don, if somebody's interested in finding out more information on the boat here and getting a hold of you, how can they do that?
Real easy. They can email me at chapinboats at gmail.com, and I'll do the best I can to get back to everybody that has any interest.
All right. Hey, thanks for showing us the boat.
Thank you, Keith, and thanks for your help.
All right.
Appreciate it. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys. How do you manage what power point you boat and what shaft and all that? All those formulas are out there on the based on those keys.